G'day, I'm your host. My name is Josh Wulf, and today I'm building a GitHub action. Let me just fix my sound here because I'm hearing my own voice in my head, which is disturbing. Let's see, I go to turn this on, turn this off. Cool. Okay, so yeah, I'm building this Camunda Cloud Starter, which is, look, serverless computing, that's so last year, man. This thing is clientless computing. So you got Camunda Cloud, which is like a hosted Zeebe broker. And now I'm going to use GitHub as the client for Camunda Cloud. So no installation of software, no installation of client libs, and actually no writing of code. So I can build automated tutorials that run in GitHub repos and require no installation on the part of the user apart from like forking a repo. So all this action is happening in the Camunda Cloud Starter repo. Getting started with Camunda Cloud with no code using GitHub and the Zeebe action. So the Zeebe action is a GitHub action that I wrote last week that automates interaction with Camunda Cloud on GitHub. What I'm going to build today is I'm building GitHub, which is a JSON database that runs inside a GitHub repo, and it uses like just flat file storage in the GitHub repo and like, you know, does commits into the repo with JSON stringified objects. All right, so to get this thing kicked off, I use this actions TypeScript action repo, which is awesome. Check this out. Opening. It's github.com/actions/TypeScript action. Create a TypeScript action with test linting, workflow publishing, and versioning. This is the one that I used to create the Zeebe action. I'm not sure exactly how they set it up as a template, but anyway, it has a button in here that says use this template. You just click on that, and then it starts a fork in your repo, but you can change the repository name here. Pretty cool. Create a repository from template. Yeah, so I've already done that step, and I've created my GitHub action repo, and somehow it knows it's an action, so it says publish this action to marketplace. Once this thing's ready, I'll publish it. Okay, so I've cloned this repo to my local machine, and I've started the action. Let's have a look. So get these out of the way. Right, sehr gut, sehr gut, sehr gut. Okay, so I've opened it up, and the only changes I've made so far is I've changed action.yaml. I've done pnpm install. I use pnpm these days because rather than installing npm installs all the modules in your local directory, and then when you have like tons of different JavaScript projects using Node like I do, you got like multiple copies of the modules in each of the, you know, repositories, each of the projects, each of the directories. What pnpm does is it puts it all in a single place, and then you just reuse them. It's kind of like, or I don't know, automated symlinking or something like that. Anyway, I use that. So I pnpm installed in the directory to get all the dependencies, and now I'm editing action.yaml. So action.yaml is the schema for your actions kind of data that users provide when they use your action in a workflow. So GitHub DB, database driver for a JSON database in a GitHub repo, my name, email address. Here are the inputs. So it's going to take an operation, and that's going to be required. It's going to be like either find, upsert, delete, or init. And then you can run a query if you're doing like a find. So you need a query parameter. It's not required. So the other ones are all optional because they are required for different operations, but we'll handle that in the code. A record, if you're doing an upsert. Table, that's going to be required for like an upsert operation or a delete operation. And then a base directory, which is not required. It defaults to DB. So this, when you use this action, it'll create a folder in the root of your GitHub repo called DB, and that's where it'll put the tables. And each table will be a file, and inside that file will just be a JSON stringified object. Okay, so that's pretty much what we have in action.yaml. Now I've gone into the main.ts and I've started coding this thing. So, you know, they've put a single async function here, so you can use async. There's no top level await yet, so they just immediately invoke it at the bottom. First thing we're going to do is we're going to grab the operation from the inputs, and you do that by using this core library here, And what the core library does is it gives you a bunch of helpers that you can use to interact with like the environment, inputs, outputs, that kind of stuff. So the first thing we do is we grab the operation. I'm going to do test-driven development because I always get myself into trouble writing the test later on. You know, it's like now I need the test and things so complex that I have to go back and refactor things to separate them to make it testable. So we'll start from the very beginning with this. I think the first thing we need to do is we need to do like, we'll make a call here to resolve required parameters. And all this is going to do is it's this is going to encode the resolve required parameters. This is going to encode what I was pointing to before, that some parameters are required for some operations, but we make them all optional at the top level. Here we'll do resolve required parameters. And then I guess what we'll have this do is we'll have this return an object, a named object. So we'll say parameters equals. Okay, I need this to return two things. I need it to return either a failure state, like there's not required configuration. Here we go. There's not required configuration, in which case we're going to have to bail. So we should set failed at this point and return. So if it fails, I guess we could do it like this. Okay. This. There we go. Like that. Kind of like go. And then what we do here is we just test error. If there's an error, then we'll bail out of here with core.setFailure, I think it's called. Set failed and error. So that will fail the GitHub workflow and, you know, output the error. So this, check the parameters. So what this means is that because I'm doing the core set failed outside here, that's a side effect. I can write this as a pure function, which makes it testable. Actually, it's going to have to do core get input. Okay, so I guess we could do this, right? We do it like this. Make the signature that it takes just all of the parameters and then just scans over them to see if they're the right ones. This will be, yeah, this will be testable. So operation, which we already have, and then we'll grab the other ones out of the environment without assigning them to. So we had table, and then so we say core.getInput. Why is it doing that? I think I've got IntelliJ open actually, because I was doing some programming with Ballerina. No, that's not open. What is open? Taking up memory. Let's have a look at my memory pressure, CPU usage, Windows Server. Oh, that YouTube music desktop app is using a bit. Can't program without that though, so we'll keep that running. I could run it in Google Chrome. Let's just keep going, see what happens. So core, and then we just get input, and this is table. This is a side input, so it's a side effect, but in terms of getting data in, so we don't want to encapsulate this in the resolve required parameters function. So there was operation, there was record, and then we'll get the input from the record. Get input, in pet. Get input, record. Ready. Okay, we've got the record. Now, base directory. Yeah. Base dir. Core.get input. Get input, and this is base dir. And what else do we need? A query, if there's a query. Dun dun. Query. Core.get input. Query, so we're going to get the query. Anything else? Look at the action YAML. This doesn't need to be so wide, so we can put that smaller. Operation query record table base dir. That's it. 1, 2, 3, 4, 5. So we've got 5 parameters. 1, 2, 3, 4, 5. Here we go. Yay. Okay, good. Okay. So let's write this resolve required parameters function now. I'm just going to export it straight from this. I guess I could put it into here, but I'll just write it here in line, and it's not a big deal that I'm exporting it because nobody consumes the surface area of this module. You know, you just like mention it by name in your workflow. Otherwise, I sometimes worry about polluting, you know, the IntelliSense for people. So export function. So what I'll sometimes do if I'm if I have to export private kind of functions for if I have to export a private function for testing, I'll either extract it out to another module that they don't import, or I sometimes will do this. Instead of exporting it, you do this. You go like this. At the end, you go const _test. What? Maybe call it like test interface or something. Test interface equals, and then you just put the things into there. So what happens then is that, you know, then you go export _test interface. Actually, no, this is too slow for me to be able to code with. No, not feeling it. You export this here like that. So, you know, people are not going to mistakenly import, you know, _test interface and get that out. Actually, I'm just going to do it like this here. That'll be cool. There we go. Okay, so this thing is going to take a complex object. Now the TypeScript linting on this thing is quite strict. So these things here return string or undefined. No, they return a string. What happens if it's undefined? I'm fairly sure that this thing actually, in reality, go to the definition, returns string or undefined. Like if they didn't define it, it returns undefined. The value is also trimmed. That's cool. Have a look at the actual implementation. So we're looking for get input. Get input. Who is using my CPU? Windows Server is using a lot. Let's try closing a few things. Don't think I need that right now. That's Outlook I'm quitting. Do I need Slack to be open right now? Yeah, probably not. Get rid of that. Quit Slack. I'm just gonna quit a bunch of stuff to get it down. Zeebe modeler. Nah, I don't need it right now. That. Do you want to save this before you... don't save, whatever. Nah, just don't save anything. Good. Discord, don't need that. Close that for now. Quit. Is that helping my CPU? Maybe. Google Chrome, up and down. Okay, here it is. So process end or empty string. Okay. Return value trim. Okay, well, what happens if you trim an empty string? I think it'd just do nothing, right? Just return an empty string. So trim that. Empty string. Okay, so it could return an empty string. Okay, so it could be an empty string, but it's definitely a string. Okay, so what we'll do is we'll define an interface at the top just to make life easy for ourselves. Interface, and it's called, I don't know, DB configuration. It's not actually the DB configuration, it's the operation configuration. I guess we'll put like, and we'll start with this. So it has all of these things here. Now, the thing about this is that this one is required and it's always going to be a string. For these ones, this is a string or undefined. Well, no, if it's a string or undefined, it means it has to be present. We'll do it like that. If it is present, it has to be a string. Wow, that light is really bright in my eyes. I'm getting fatigued already. What does this do? It's down. I think this one? Yeah. And the brightness down a bit. Good. Okay, and this one here is also a string. Save it. Is it auto format? Yes. Good. Okay. So resolve required is going to take one of these. So I guess we'll call it a config. And then say that it's a DB operation. Okay, we'll do a case. Ooh, okay, no, let's not do a case. If I do a case on a string, there's no way for TypeScript to like reason over the exhaustiveness of the case, the switch case. So what I'll do instead is I'll make this like a discriminated union, I think this is called, of string literals. Is that a discriminated union? I think so. Now it will complain that you can't pass that in because it's the wrong type, it's a string. So here, I think what we need to do is go, okay, this really is the DB operation. It's one of these. So I'm gonna have to rename this object. What is this thing? It's a DB getter operation with parameters. So there's a better name for that. That will be shorter because I'm not programming in Java. And then we'll typecast this here. We'll assert that it's one of these. Problem here. Oh yeah, okay. So I'm gonna go down here and change this to this. I mean, it might seem like, oh man, this is so much trouble for this, but it gives me things like exhaustiveness checking, which is important. Why is exhaustiveness checking important? It just means that my code is, you know, the compiler can reason about the completeness of my code and that have you dealt with all the possible cases, which ultimately flows back to, did I capture all the cases in the, what is it? Is it switch? Yeah, it's switch case of. I used this for the very first time the other day in my Zeebe GitHub action. Switch is not something that I've used prior to that. I mean, I know of its existence. I know some people say don't use it. And I think you go like this, right? And then we just go case. And now we can put the cases in here. And this is where this IntelliSense comes into play, right? Like if I go like this. Can I do control? Nope. Yes? No, I'm switching on the wrong thing. I need to switch on the config.operation. Ta-da! That's what I'm talking about. Okay, so if you do like this, and then the very first thing you write is break. Break. Make sure your fingers are in the right place. Okay. Now, you know, init needs doesn't need anything. You should define the return signature as well. So there's no error. And let's return the config. Oh, brilliant. Love it. Okay, yeah, I got it. Okay, well, it's easy to do this then. Don't have to do named parameters in that case. In the return signature. What's the problem here? Type gettodb operation with parameters or null and or undefined. Well, let's just make sure that okay, it might return undefined. Well, once I've got completeness in here, so let's make the completeness and then do the signature. So next case, delete. Break. Next case is find. Yep. Okay, you got to put a colon in there. Same thing here. Same thing here. Case find. Return. Break. Okay, so let's do the happy path. Config. Yes. Unreachable code detected. It sees that it can't get to the break statement, but we'll keep it in there. It would fail if I tried to run the like linting tasks on it now. It's okay. Delete upsert. Net. This is it, huh? A wizard, eh? I think we can just like paste it. Yeah. And then break. Oh man, this thing's so slow today. Maybe if I rebooted my machine, maybe. 4 operations. Is that what this thing does? It does, yeah. Okay. If we go back to here, it's now fine. Yeah, okay, great. So it's not even parameters here, it's config. So we'll call this config like this. Very nice. Okay, so now what we need to do is like, in this case here, we definitely just return, so we don't need the break statement because init requires no parameters at all. Now delete requires, I should write some parameter helpers. I'll just do this. So for delete, we're going to need, what do we need? I think I do need to write a parameter helper because I'm going to have to return, yeah, I'm going to have to return a, write as a separate function here. We have to, I should refactor this out into its own file then. So what this does is it generates an error message. So required parameters, takes a config, takes a config and the required parameters, checks if the required parameters are in the config, and if they are, it returns null, missing parameters. So it takes a config, which is of type gettodb operation with parameters, and then it takes an array of strings. So these are called the required parameters. And that's an array of string. And then it's going to return either false. This is a weird signature, but I'm just going to go with it for now. Or an array of strings, which are the missing parameters, right? And then all it needs to do is, well, okay, so yeah, missing equals, and then what we do is we take the required parameters and then we map over them, and then here's the parameter, and now we're going to return I'm going to examine that config.p. See if the parameter is in the object, and if it is, then I should return null, and if it is not, I should return the name of the parameter. Okay, so I think I have to just cast this as any in that case, or as object maybe. In which case I need to cast the object first. And then do that. I think there's another object type like this. Nope. Okay, well, we'll just erase any type information like that. Okay, so then the next thing I need to do on this is filter it to get rid of everything that's filter it to take out all of the ones that did exist, so they've put a null entry into that array. And that's pretty simple to do. I just do element and then use JavaScript's truthiness to do that. If I save that, is it going to stack them? Nope. Okay. And then I just go return if there's anything left in that array, it is a missing parameter. There we go. That's the problem. Okay, it's gotten the idea. I wonder if it's smart enough to be able to parse this and see that I've taken the nulls out. Can I work that out? No, it can't. No, that's the wrong. Like this. Interesting. So it can tell that I'm mapping over this thing and returning a string or a null. But it can't tell that in the filter, I'm taking out all the nulls. Interesting. Well, oh my goodness. Huh. Okay. Yeah, okay. It's just like, I don't know. When you take advantage of the dynamic programming capabilities of JavaScript, so then I just got to do this. Yeah, okay, that's pretty disgusting, but yeah. Okay, well, so I'm writing like a generic helper. It's generic. It's a generic helper function. Once you start getting into generics, it's and especially when you start. I'm leaning into the fact that I know that this object here is actually a JavaScript object with string keys, but that information is not available or encoded, because hypothetically a JavaScript object could have like symbol keys as well, which are not strings. So anyway, whatever. That's how you get that to work. Okay, dynamic programming in a statically typed language. Okay. So now what I do is I'm going to call this function here. Well, I could test that function actually. And what we'll do is we'll just delete all these with Command D, get rid of those. Where'd my thing go? Back. Okay. Alright. So we should be able to test it then. Should be able to test it. Missing parameters we should be able to test. Let's write a test for it. So the testing functions in this action TypeScript thing are up the top in _test. It looks like it used Barest or something. It doesn't. No, it uses Jest. It's got a jest.config in it. Okay, so I want to run this test. These are the tests from the original wait function, which we're not going to really be using, so I'll delete that actually and get rid of it. Delete. Move to the trash. Yep. Go back here. Test doesn't exist. Get rid of that. Source, so we'll just get it from the main. Actually, now is really the right time for me to refactor it, because so we'll create a new file now and we'll just do parameter. What is it? It's parameter parsing? We'll just call it parameters.ts. Helper functions for parameters, right? And then if I go back to main, I can just now grab this and go X, get that out, save it, go to parameters and paste it. Save that. Okay, well I'll import this from the main file. Oh. Give me an option to import it? That's funny. Yeah. Weird. I'm not sure why it's not able to parse it. So we want to import this from /main, and if I go here, I can just go, oh, it's not exported, that's why. That would be why. Okay. So we're going to export this, we can get rid of this wait function because we deleted it. Get rid of that. I actually need to export that, so I actually don't need to do this test interface anymore, so export from here. Export from here. Save that, and then I should be able to import this thing now. There we go. I got to export this interface as well. Actually, I don't know if I need to export that. I don't think I do. That's cool. Now can it see it? Yep. Here we go. Save that. Okay, cool. These are now pure functions. They're in their own file. Yeah, we're not using that, but anyway, let's do this. Okay, so first thing we want to do, well, this is main.test, so we should create another one called parameters.test. Parameters.test, and I actually did some of this in my head rather than as a test. It's like, oh, it's going to take this and it's going to return that, and inside it's going to do something. Just comment that line out. It's fine. Comment out the whole test. It might fail saying there's no assertion. No assertion in here either. Okay, we've got parameters. So, okay, so first thing we need to do is import this parameters. There are two functions in there that we want to from. And it comes from dot dot forward slash, no dots on the other side in Helmac, dot dot forward slash source forward slash parameters. Okay. So we're going to test something. What are we going to test? First thing we're going to test is this missing parameters one. Parameters. Yeah, I'm not really familiar with this. I'm used to describe in it. That's what I've always gone with, but whatevs. How different can it be? So if we have an operation, so we're going to pass in this config, right? So config equals, and it's an object. Let's just have a look at this parameters thing. No, I actually did say it has to be, I can't just use any object. I've got to use a specifically shaped object. If I go here, let's do this. I say missing parameters. Will it give me IntelliSense on? So it needs a string keys here. I wonder if I can do this. So in here we can go something like this. It's going to be a partial, like advanced TypeScript stuff. Partial of something like key of. Okay, I'm actually gonna look this up because I want to do it. Dun, dun, dun. So, create a new thing for me. So it's TypeScript partial key of. It's the Google search that I'm looking for. That will find me what I'm looking for. Key of. P and key of T. Why can't I grab this and put it there? Let's have a look. Let me have a look at this. Came in 2.1, we're now up to 3.7, something like that. So it should be in here. And then there's this advanced type one. Utility types. Key of and lookup types. Okay. APIs expect property names as parameters. Yeah, see? So far it hasn't been possible to express the type relationships that occur in those APIs. What I'm looking to do here is I want to erase this hellish type erasure I'm doing in there. Okay, so you've got an interface. K equals key of person. Okay, so I've got to give it its generic signature here. I think I say here that this is an array of K, which I think you have to write like this. It's either going to return that, or it's going to return an actual array of these things here. I think if we take this out, is this going to work? Okay, look, it's got the K has gone through, but it's got the same problem with this null. Okay, so there must be a way around this problem, right? Which is that TypeScript filter remove null elements. Type predicate. Strict null checks. Okay. Here we go. It's the exact problem. Let's have a look. 7 answers here. Type predicate function in the filter. Okay, so oh, I see. Okay, so you use a type assertion. Okay. Well, yeah, we're gonna do it. What? I don't want to print it. Hello, come on. Oh, what is up? Choose Control C. Something is running on my machine that is chewing up its so if I did do this, so the way this one works is it has a type assertion on the return signature, and it asserts that if I give you back a value, it's a value. So what I do here is I just go like this. Ta-da! There we go. So, see, I had to use generic type signatures to do this because I've written a generic, you know, using JavaScript's dynamic kind of features. I've written a generic, I don't know what you call this, a generic function that does something to something. And what TypeScript needs is it needs the information about, you know, your intentions on what you're generically operating on and how it transforms that. So these type signatures here are an expression of the relationship of these generic operations to the base types. So I'm basically telling it that I'm giving you a type, and then I'm giving you an array of the keys of the type, and then I'm going to map over this thing. I'm going to remove some of them from it, and then the ones that I removed, I'm going to take them out of the array, which means that everything that's in there is actually the thing. Anyway, enough of that. What that means now is that in here, since this is generic, it needs to know what this is. So I think if I do this, if I tell it that my object const valid, so it's going to be a valid what? Just any valid operation, right? I'm going to have to grab this in. So we'll go back up one, grab the src out of there. Yep. So I'm going to tell it that it's one of these. And then create the operation, right? Now, what's a valid operation? Let's say that we're doing operation insert, right? So if I say operation, ta-da, upsert. This is what, when you put this typing system in like this, you get this kind of IntelliSense. Well, let's use the IntelliSense. Okay, a base directory, which it doesn't need, so that's not required. But it does have to be present. No, it doesn't have to be present. Well, for upsert, we would need table and a record. Customers. And then a record. Okay, so this record is, it's going to be JSON stringified. Name something. That's it. Database schema validation, that's level 2. So if I now put in here valid operation, it knows it's a ghetto DB, so it knows that this must be an array of no, it can't infer it. Should know that this is an array of keys of this object here. Unknown, never. What do you mean unknown? That's not unknown. Maybe I have to tell it, maybe I have to like explicitly tell it what it is. No, I should be able to infer it. Anyway, we're going to say that what it has to have is it has to have a table. And it has to have a record. And actually I could lift this into its own function like a declaration block. What doesn't it like about that? Type of never. Why can't it? That's why. Yep. So now if I do this, oh, look at that. This is genius. I love it. Love it. So good. Okay, so here we should expect this to be false. So just say to be false. Okay, and then let's do an invalid operation. I think that should be sufficient for testing this function. It's not really an invalid operation, it's an operation missing parameters. So const operation missing required parameters. I mean, there's a long names, but I don't have to write any comments this way. It's just pretty clear. Literate coding, I think it's called. So we're going to create another operation here. Just let it know what this is. Okay, operation is one of. Okay, so let's say that we wanted to delete something. And it requires what? Yeah, I should encode this in a table. What is it? You're going to have to specify the table, and then you're going to have to specify some kind of like an index. We don't have an idea of indexing yet. Like do you have to specify? I'll just make it, you have to specify the entire record. It's easy. But we won't specify the record, and we'll say that do require it. We'll pass this one in. There we go, it needs a table and a record. So we should say includes. So it should be an array which includes record. Type false. Do it like that. Yeah, I should. think if I do this, I can extract it into a here. This refactor, extract to constant and enclosing scope. Ta-da! Let's call this missing. So the first thing is that we should, can I say to not be? Not be. No. Okay, well, we'll use JavaScript's amazing truthiness and wait to true. To be true. Okay, so yeah, we know it's true. And then we should expect, and I'm going to typecast it in here, I guess. Expect it to include. So first I cast it as a string array. And then includes, and it should include record to be true. And then I guess finally, let's make it require something that it doesn't really require. Make it require query. So finally I should expect it to have two elements in it. So expect I could have typecast it actually here. I can do it here. This will be easier. I won't have to do it twice then. Typecast it. Then I don't need that. And I don't need this. Good. Okay, so expect missing length to be 2. Yeah, I'm thinking ahead, but I don't want to imperatively define this. I want to declaratively define it as configuration. Like, these are the required parameters. Okay, I'll save this parameters block. Let's see if the tests run. npm run tests. Here we go. Testing. Testing, testing, 1, 2. Yep. Okay. And just for my own peace of mind, what we'll do is in here we'll just whack in a console log. Just momentarily. Save that and run the tests again. Actually, if I make it declarative, it's sufficiently generic that I don't even need a case statement I don't need a case statement. It's really all I'm doing is I'm applying, see how it's already repeated here? All I'm doing is applying a known string array based on this here. So I could do this. Okay, so required parameters for operation. The type of this object is going to be, it's an object. And then the key of the object is going to be of type don't know if I can do this. Can I do this? I'd like use a concrete type in here. Can I put a concrete type in? Yep. Maybe I can do it like this. Give it this single K. Oh, maybe I can just do this. Take off this generic here. Nope. Maybe I could do it like this. Oh, amazing. No. Key is not that type. The key is the type of the ghetto DB operation. Ta-da! Yep. Import this from here. And then each of those is going to have, it's going to be an array of key of, so this is a complex type, so I've got to use this type signature. Key of this object here. No, it doesn't like that. Let's get rid of all these other ones so I can just focus on this for a second. Humana. Ta-da. Okay. It's an array of a string, but it's a specific string. Is it like this? No. Maybe I need to create another type. Let's try it. This is just for my own kind of edification here. Always good to learn while you're doing something. Well, we'll just say this. This. Okay, what doesn't it like about this? Oh. Oh yeah, okay. This old bugbear. Can I be a union type? Consider using a map type. Might as well get this resolved for myself. I've looked this up before and solved it, but I never remembered it. Quick fix, that sounds good. TypeScript issues, cool. Okay, a lot of discussion about this. Let's go to the bottom. Okay, so apparently you can do it like this. And key of. Ta-da! Okay. So we should now get sufficient IntelliSense on this. Okay, so the key is going to be one of the keys of these. So these are like... I do this. X is a number. It's weird. Maybe I copied the wrong code. Key of alias type. Okay, so key is type parameter. Data table. Open on types. Implements A. Extends bar, key and foo, A and B. Yeah, okay. Okay, so the type is just key in. Ta-da! That's what I was after. Okay, so the init operation takes, and then if we go here, yes. So the init operation requires nothing. Very good. The delete operation is going to require table at the very least. What else does it require? A query? A record? Let's make it require a query so you can do deletes with queries. Find operation is going to need a table and a query. An upsert operation is going to require a table and a record. Did we need this? Key of ghetto, we did need that. Okay, so required operations for parameters, resolve required operations. So all you're going to do now is pass in missing parameters. You're going to pass in required parameters for operation based on the operation. So I can literally now just do this. Missing parameters. And then I'm going to pass in config.operation. And then I pass in required parameters for operation config.operation. Ta-da! Can't key it on the type. That was my mistake. Ta-da! Look at how simple this code becomes now. This is like functions over data and using typing to... So now, we're going to return one or two things. What does this return? This returns missing or false. So if missing is true, we're going to return missing things and nothing for the configuration. Or we're going to return no error and the configuration. Functional programming. Okay, so a lot of that imperative kind of logic is now encoded in the type system, and it's declarative. So now I can just come in here and like change this easily to mutate, and then I don't need to worry about, I don't touch this code. This is just transformers over data. Okay, so if we go back to our tests and see if they are still okay. Freaking out about the test? No? Okay. Let's run the test and see if it works. Ah, no, I shouldn't test this thing anymore. No, shouldn't test it. Okay. Let's test this. Okay. This is now a valid upsert operation. It's going to be interesting. Add this to the imports. So I think that's all we need to do. The return signature on this is error, missing. No, error, config. So what we would expect to see after running that is we should expect error to be null. And I mean, we're testing two things here. We're testing that that function works. We're also testing that an upsert requires a table and a record. So we'll just test that we're getting back the object we expect. The return type is not right. I see. Zeebe operation with parameters. What does this return? Okay, it returns. I know what this is. I think we can do it like this. It's a tuple, it's called. It's like a specific, it's an array with specific types on the elements. So the first element in this array is either null or it's an array of missing keys. An array of missing keys looks like this. And then the second one is either a getDB operation with parameters or null. Ta-da! We go back here, we'll still have the same error. Yeah. So we got to assert that this thing is the getDB operation. Well, I mean, you could do it like this. Ah, no. Actually, way better than this is it's either one or the other. It's not like a thing. There's not multiple permutations, so it's either that, or if I copy this, then I can use a type guard. If this is null, then we get back a configuration. We can't get back null and null. We can't get back errors. So if that one is not null, then this one is null. So it's either going to return back either an error or a config like that. That's the actual tuple signature that it returns. So in here, I can say if error is not equal to null, of course, I'm not going to do this because then my test would potentially break. Nope, type guard didn't do it. Okay, it's not smart enough to detect that. If that's the case, then this must be like if that is null. So if error equals null, nope. Nah, type guard doesn't work. It's unfortunate. They'll make programming a little harder. So in that case, rather than using a tuple, the other way to do it is you can return an object, right? Like this. You can either go missing keys. This will be easier. Is that and null. And then the config is null. Or else it returns one where missing keys is false. Missing keys is false. It's a Boolean literal, so we can write a type guard on it. And then the config will be one of these. Oh gosh, this is turning into like an advanced TypeScript programming session. So in that case, what we do is we do here, this is missing keys, right? So we can use object literal shorthand. Missing keys, config is null. Otherwise, we return this might give it enough information false. That might be enough information for it to do the type guard. Config is shorthand here. There we go. Rather than a tuple, we'll do it as an object. Now, if I now say config.config.error, what would you call this object then? It's a higher order object. It's called parsed. So we should expect pars.missingkeys to be false. Expect that to be false, right? Okay, so now, because we're already testing it here, we should be able to write a type guard in here. Now, if it doesn't equal false, type guard, no. Oh yeah, parsed.table. So it should be able to cast it within this block. Nope. What does it say? Object is possibly null. It can't, I know for a fact that if I make that missing keys true, okay, so in that case we'll just do a different guard here, which will be valid. But this is valid as false. And then we make this one valid true. This will do it. It can definitely discriminate on that. Then this here should be null. Okay. So in this one here, we're going to return valid is missing keys. There are missing keys, so valid is false. And in this one here, valid is true. In which case this has now become null. So that fixes that. If I go back in here, so this one here, valid should be false. Hang on, no, valid is actually true. Now because we just tested it here, we can just use this as a type guard. Because the test will fail if it wasn't, and that typecasts it. Yes! Love it. And we should expect this one to be customers. Now we changed the signature in here, so we're gonna have to go back up to the main where it's gonna say wrong return signature. Firstly, we've got to import this from parameters. Call this parsed config. Now, if the parsed config is not valid, then we're gonna error out and pass out the parsed config.missingkeys. Ta-da! Possibly null. Oh yeah, okay, it's an array of strings and this needs to be a string, so we'll just JSON stringify it. And we'll give it a better message as well. This. Missing required configuration keys for operation tar. For this operation, which is operation. Run the tests. Did I miss something at an earlier time? Checking my messages, actually. Have a look. Okay. What do we got here? Missing required configuration keys for operation. Yeah, okay, the test passed, so the test run. Let me just reason about the completeness of my test. No, I gotta expect an invalid. I mean, I could write tests for... I mean, I'm testing that my generic function works, but I'm not testing that... But that's pretty much... Yeah, I don't need to test that. This is the statement of it here. Delete needs a table and a query. So let's pass in... Could extend it to make tests for optionals and say, hey, you've included this optional property that will be ignored, but I'm not going to do that right now. So the operation here is a delete operation. And we're going to pass in a table. We'll call the customers table again. Let's have a look. Delete needs a table and a query. So what are we going to say? A record? What happens if it needs a record or a table? Okay, then we're in trouble. I have to extend it. I'm not going to do that right now. Let's say we pass a record to delete, right? It's actually safer to delete records, I think. But whatever. So, yeah, so we're just going to pass in some record which is not going to work because it needs a query. Something. Put your fingers in the right place. Something. Yeah. So resolve the required parameters for the invalid operation. And we should just expect it to say that there's an error. So we should expect valid to be false. Yeah, what happens if there's optional or discriminated unions? Like you could do it on this or that. I'm not going to support that initially. Okay, it works. I'm not sure whether it returns the default if you've specified it. Get core get input. Does it return a default? Let's have a look. The GitHub action. So core dot. Well, hang on. No, we were looking at the code for it a minute ago. Let's look at the source code. Core get input. Okay, so it looks for it in the environment. Yep. Okay, so if it does get set, so it's not actually this library, it would be set by the GitHub runner. So GitHub action default action.yaml. Not what I wanted. YAML. No, this is the workflow syntax. Inputs. Okay, it does actually default to it. I think so. Let's have a look at outputs. We need to output the record. Output parameters declare data that an action sets. Can use this output. Okay, so what about returning multiple records? Okay, so yeah, I'll make them always return an array, I guess. It's easiest. Metadata. Yeah, I'll return a metadata array. Okay, so let's make it real simple, right? Okay, so we're in here now. Validated configuration. I'll put the different operations in different files then. So let's create the init operation first. I guess I'll make a folder called operations. To like semantically encode in the structure of the project what these things are. And then so the first operation is called init. Okay. The init function, what the init function does is it returns a list of the values that you can, the operations that you can perform. Which are where? Parameters? The test. And here, going to return I think I just take that out like this. Well, we'll just say it's an array of strings and it's easiest. So what I want to do here with init is I want to return an array of string constants for the operation. So actually what I'm returning is this. I'm going to return an object. Can I import this? Yep. Key of ghetto is not exported. So export it from here. Now I have these types spread across two different files, which is an anti-pattern that needs refactoring. This one here. So I can actually get type completion here. Doesn't return an array and a key of ghetto. What's this key of ghetto? Can I do this? Nope. One of, can I do this? I'm doing this because I want to have strong typing on here. Delete. Oh, type. Oh. Okay, so what's wrong with that? Oh yeah, okay, it's got to have all of them. Good, see, it reasons about the completeness. That's why I wanted to have this. So when I extend it in one place later, it will tell me about all the other places it needs to be extended. These are the different operations that you can perform. Ta-da! There we go. Very good. So in the main, what we'll do is, this is going to be so easy. I just go core.set output. And then we'll just have a thing that's called result. And then we'll just JSON stringify the result of the operation. Stringify operation result. So see, this code here in the main function is not concerned with any implementation. It's concerned with marshalling data in and out of the actual operation. So here what we'll do is we just go const operation result. This is going to get dynamic here. We're going to await the operation. So operations, right? Parsed config. Passing the parsed config to the operation. Like that. And then we'll just call this dot result. So we'll make a normalized interface so it's going to be the same every time. So error. So in here, okay, hang on. If it has an error. Okay, so I'll have to do this. Okay, this is a pretty ghetto DB. It's going to be. And if there's an error, then we'll output that. Winning. Very good. Now to get this operations thing to happen, what we'll do is we'll go into operations, create an index, and we'll export a keyed object. If I go back to main, what is the type of this? DB operation. Yeah, okay, so index. We'll export a typed object that's keyed on that. Default? Yeah, okay, so I think to do this I need to do operations like this, and then I gotta go const operations equals now this is going to be a keyed object. I'll take my inspiration from here. It's going to be keyed by DB operations, yeah, by this. The type signature of this okay, but what it's going to return is a function that takes a config and that config is of whatever type this thing is. So what's this? Nope, DB operation with parameters. I'm going to take this. We need to import that from wherever it is. And it's going to return an object which has an error, which is of type any, and a result, which is of type any. Just do that for now. Okay, first operation, init. So up here, I'm going to import my init function. From here, what do I have available for my export? I'm going to have to change the signature of this function because it'll say, hey man, that thing doesn't take the right parameters. Yeah, it doesn't return, it doesn't take the right inputs. So here we need to go, this thing's going to take a config which it doesn't use. And it needs to return this. Okay, what don't you like about that? Ah. Uh-huh. Okay, what's wrong with this? Maybe an error. Actually, no, I can do it like this. Error is false. False. Okay, here's my index for the operations. Doesn't have all of them in there yet. Good. This is looking good so far. I'll put dummies in here for these other ones, right? Delete. Let's make it here. Okay, so it's got type widening, so that should work. And then since these are set to any, I can just return this. Not implemented yet. So actually that should come back and this should be null. Let's do it like this. Actually, this is much better. I do it like this. Not implemented yet. Okay, and I gotta let it know that I'm actually returning an object. And then we just call this not implemented yet. Easy. Find not implemented yet. What else is missing? Upsert. Not implemented yet. Yay! Done. Like that. Okay, very good. Operations, so let's have a look. Yeah, okay, I gotta get operations in here. So I think I go import operations from ./operations. Save that. Yeah, okay, good. It's caught the error that I was hoping it would catch. Done. Okay, functions over data. Left the concerns into the type system. It's good. Good. Okay, so I mean, one thing I could do is I could say that no, it's sufficient. Actually, I could, like, in here, this type here, could say type getODB operation. This is going to make it a lot easier. It's a function that takes this. However, it's actually because I put the error message in there. Yeah, it's fine. Leave it like that for now. Oh, so this is actually a getODB operation implementation. Which means that what I can do here is I can say it returns a getODB implementation. And I can also assert that this is a getODB implementation. In which case I need to do it like this. I don't have to specify the return signature. In which case I can flatten this further. Save that. Okay, import this from, I've got to export it from here. Oh, I've got a default export here, so I can't. So I need to put this, I guess I'll just put it in here as like utils. this. Put both of these in there. Export this. And export this. Okay. Export this, export that. Need to import this. Here. Go back to util, save that. Okay, so I should be able to get rid of this. Bring this in from outside. Import from utils. Import not implemented yet from utils. Save it. What doesn't it like? Nope, it likes it. It's good. Which means I can go back to init here. And this one I can import from utils. Get rid of this. There we go. Good. Okay, and main. It's good. Okay, I guess I'll write a test for init. That JSON marshalling piece as well. Do I need to test that? I don't think so. It looks pretty simple. It's like it just JSON stringifies it. Should be fine. That's all there is to it. It's real simple, man. We grab the configuration. We check to see if it's valid for the operation they're requesting. We perform the operation, and then we set the result if there's a result. We set the error if there's an error, and we're done. That's it. Separation of concerns. So parameter validation takes place in here. We'll resolve the required parameters. Let's put this at the top. So you don't need to touch this code in here, except when and if we do like discriminated unions of required parameters. But we'll try to avoid that in the design. That will complicate, but that will complicate only this section, because by the time it hits here, we know we have the required parameters for the operation. Okay, so init will return this. What's the next operation that we'll do? Let's have a look. You know what? I think this should go. I'll cut this. I'm going to put it in here. I think it should go in here. That. One thing I could do then, change the name of this to that, pass it into the function. No, it makes it not testable anymore unless I have access to this. If I run my test and it requires this, it's going to execute it. It doesn't work either. Yeah, okay, I need to undo that. That needs to stay in here. Sorry, can't bring it in here. Yeah, no way around that. It'll break the testability of it, because this is like fully side effect. Side effects, side inputs, and then side outputs, and then like very little in between. Okay, do the next one. I guess upsert. Let's do that. That's a little bit. This will be fun. So we'll do upsert. Okay, so we'll define a file upsert where our operation will take place. I'm gonna have to do some file system shared utilities for this. So upsert. Yep. Okay, we'll copy the init code here. Part at least. upsert operation. Upsert. Okay, we actually need to get the config, and it's not any, so yeah, I should have been stricter on my typing there. So if I go to main, we know that the config.config is this. Double check that. Yeah. Okay, I don't even need to define the type on that. It'll automatically infer it. See if I go like this. Ta-da! Beautiful. Let's write the return signature straight up. Error and result. Okay. So, I can't constrain it. What would be really nice to have in here is to specialize the parameter type so that I know in upsert which ones I have, which would be chained to the required parameters for each one in here. Specialization. So it's a partial of it, but it's which partial. So this here is like, because I'm dynamically, everybody who doesn't have a type system is doomed to re-implement one at runtime. Yeah, that's basically what I'm doing here. I'm re-implementing the system at runtime. So in that case, the way the signature would work is instead of it being like this, this would specialize. So the way I would do that is I'd do interface, and instead of operation, I'd have a string literal here, and I'd have the required parameters and not required parameters. But the interface stuff is erased at runtime. The other way to do it is like Nest.js does it through the use of classes. So I'd say I knew this operation and pass in the required parameters. Actually, that's another approach. Rather than parsing the parameters, I could implement each operation as a class, and then in the constructor the class would take in its required parameters, and if it didn't have them it would then throw, which means I lift the concern for parameter calculation out of here and out of this table and into each of the operations. They're each individually responsible for throwing if they don't get their required parameters. An upsert operation requires one of, which would actually make it easier for me to do the discriminated union stuff. So I wouldn't have to do it declaratively. So we wouldn't sanitize the parameters, we would just run with the operation, and the operation would be responsible for communicating back if it didn't get its required parameters. It would just return an error. Would we want it to continue on error though? Wow, that sucks. What's on there? Chewing gum. Okay, as a design consideration, I mean, we need to communicate two different types of errors. I could not perform the operation you asked me to because you didn't give me sufficient information. And the second type of error is I tried to perform the operation that you told me to, and it failed, which we should set failure in the workflow. Should we set failure in the workflow for both? We should. We should fail the operation in both cases. Okay, after doing all that work, am I gonna now refactor it to put it into the class? Whew. I'm gonna roll with it like this for now, and then we'll come back to it later. Refactoring it to that shouldn't be too difficult. And the only thing is now I don't have the information about what required parameters, what this thing requires, because they live in here at runtime. So I can't get them into the upsert operation. Anyway, table and record. Let's just do it. Table, record, and database. I'll just destructure them off it at the top. That'll make it easiest. Oh, give yourself a hand here, man. Base dir? Yep. Okay, let's sketch this out. Okay, check if table exists. If it does, read it. Okay, so find existing record. Now this is an interesting one because how do you find the existing record? Maybe we need to have a query which is like a partial match. What if there's more than one match? I guess if the record doesn't have an ID on it, we'll assign an ID, right? So we'll just by so if the record that they're sending in, and what does it think this is? String. It's a string. This thing here should be a JSON record. Okay. So we just go JSON record equals JSON parse. Now this can throw, so we'll catch it, and this will be one of our first errors that we'll have to throw. So we'll try this. I'm not going to get the JSON record. Yeah, I mean, if this throws, we have to blow up. Catch. Everything will happen inside this try catch block. It would have been good if they'd put a different interface on that rather than throwing. So if we catch, we're going to have to return an error could not. So what we'll return is error. Could not parse record to JSON. And then we'll just emit the message so that they can get a bit more sense of like what actually went wrong. So that's that error, and then the result is null. No result. Sorry, you were denied. Okay. Okay, I got to do an assertion here. We know it's defined by this stage. That's the other thing is like when we do this parameter sanitization here, we can't then assert that it does exist afterwards. It's still config here is this ghetto DB operation with parameters, but it should be one of the subtypes. But we can't, I don't think I can key on a type. No, not without doing a lot of extra. Forget that. Okay, I guess I could do it in here and say it's this kind of operation and it definitely has these things and then typecast it here, but that doesn't do runtime checking. So yeah, if I lifted the checking out of here into runtime checking in here, I could assert the type there. Anyway, not going to do that now. Okay. Well, we should do this straight up, optimistically, because if we can't do any of that, then game over. No point doing the rest of the stuff, right? So after we parse the record to JSON, we can just do that straight here. Yeah, good. Don't need to put the rest of the code in the catch block. Do because I can't get I have to let JSON record here in that case. This is what I don't like about the interface of this JSON parse, the way it throws. Okay, JSON record. So I got the JSON record down here now. So I'm going to find the existing record further down. Save this, check if the base directory exists. If not exists, create it. So it should go into the utilities function, I think. File system. FS driver. File system driver. Okay. So export a function called create base directory. It's more like assert base directory, ensure base directory. Yeah, because one of the things we have to do in here is we're going to have to do a commit to the Git repo. And this takes a base directory, which is a string. And then we just do this. If directory exists. No. What is if dir exists? No. Dir sync. Okay. Let's do this. Import star from FS. From FS, yeah? Yep. Maybe I can just do FS from FS. Yep. Okay, let's see if we can find one that says exists. Exists sync. Here we go. And then what we'll do is we'll put the base dir in here. We're going to put a // in front of it, which needs to go inside here. Yeah, so they could put it in a hidden directory in there, I guess. Okay, it's synchronous, so there's no need for them to await anything. But it could throw an error. Okay. Could not create base directory. So is each one going to have to do that? I guess so. Okay, so otherwise what we're going to do is we're going to create the directory. Okay, does it do recursive path like options? Options can be a string, a number, make directory options. Well, we'll just try this. I think I normally use like some kind of extended FS extra or something. See what the options are. Recursive, good. That's what we needed. True. Yay, it's like we're living in the future. Well, I'd say that this can probably throw. And then we'll catch if it catches. Catch. A. Maybe I just let it throw and it fails. Yeah, we'll just do that. That's easy. Don't need to communicate any more information about that. Okay, so we've got to ensure that the directory exists. Ensure base directory. Pass in the base directory here. Okay. Okay, so I'll make another one in the FS driver called read table. Actually, I'm going to make this a class. Because I'll just want to put the base directory in once, file system driver, and then I can just put that in the constructor, and then they just construct a file system driver. Like this. So and then this here just becomes the constructor. And then we just say if it doesn't exist, make it. And that will throw and cause the whole thing to stop if it needs to. Okay, constructor, what's it not liking about this? That goes for that one, that one's for that one. Oh yeah, okay, we need to close the class, so save that. And then what we need to do here is go to this base directory, state that persists over operations. Instead of having to pass it around all the time, I'll just put it in a closure. Okay, this base directory equals base directory, declare it as a property. And then so what I do in my upsert is I just go fs equals new file system driver. Pass in the base directory. Import this from the module. Ta-da! Don't need that. Oh yeah, we need to assert that that is a string. Ah, that sucks. I mean, I could do this. And we're raising all the typing all the way down. Now I need to assert it here. So if I do fix that problem with this typing, I don't need to touch the file system driver. Okay. I know that this is the right type in here, but the typing system doesn't. Whatever. Check if the table exists. Okay, so now we just got to do const table equals read the underscore table. Table as table name. I think the way you do this is you go do something like this. But maybe it's the other way around. Oh. Okay, cool. Table name. So here I can read the table. So I'm going to create a method called fs.readTable. And then we pass in the table name. Onto my fs driver, make a read table name. Tests? What tests? Read table, and it takes a table name which is of type string. So I'm going to have to assert that that is actually a valid string in the caller. So now what we need to do is check if the table exists, right? Yeah. Exists sync. I'm gonna do that. Okay, this dot base name. Base directory /, and then the way we'll do it is we'll go table name, and then we'll just put it in a folder called data.json in there. That's how this works. Okay, now if that exists, then we'll return fs.readFileSync. I should make this to a helper function, so because I'm going to need it for writing the table as well. So make this a private method called get table file. It's actually table file name, and it takes a table name which is of type string. It's going to return a string. C, and then I just need to return this. So here we just go const file name equal this dot get table file name, pass in the table name, file name. Okay, this also can blow up. I'm not going to do any handling in here. It's like if it blows up, it blows up. Like if you edit this file and corrupt the data. So we need to read it in as UTF-8. So read it in as UTF-8. And then we're just going to JSON parse it. Okay, would I make it human readable by stringifying it? I could do. That'd be interesting. Yeah, I'm going to do that actually. It'll make it, yeah. Could be an option. Otherwise, we're just going to return an empty database. What do the data tables look like? Are they just arrays of records? It's the easiest way to do it. Yeah, why not? It's an array of records. No schemas, schemaless database. Insert that it's a string here. Find an existing record. Okay. Woo! Okay, so const existing record. So I just take the table, I filter it, and each record just only if the record ID equals the new record dot ID. JSON record. JSON record. There we go. Implicitly has any, so no implicit any turned on in this, eh? Okay. Okay, so what I can do is in here I can tell it what I'm going to return. It's an array of any. So fix that. Yep, any. Okay, so if there is an existing record, what happens if they... no, you should not be able to upsert, or they could... No, it's only upsert, so just replace it. Okay, so I've got an object in the array. Let's just test if it mutates it in place. If that's the case, let's write the thing out. I think it does. Const table equals, so I make an array with a couple of records in it. ID 1, comma, data 1, and ID 2, data 2. ID, let's see, data 2. Okay, so now run my table.filter. No, const record equals table.filter. Filter, and then this record, and then we're looking for the record whose ID is, so r.id equals 2. And then record should now have that. And if I say record 0 dot data equals updated, if I now look at my table, yep, okay, so I just need to update it in place. All you need to do is this then, so you just go existing record 0 equals record, JSON record. Ta-da! Done. And then I just got to do fs driver flush table, and I'm done. fs dot flush table, I guess. Flush table, and give it the table name. And the table data, which has now been mutated. Do I want to put metadata in there, like updated at this time? I think so. Put a metadata record in there, right? So I'll do it like this. Updated. How do I get like a nice date time string? New date to string. Oh, yeah, that's fine. Just like that. Timestamp. Actually, that might be some kind of weird object that doesn't serialize properly. So let's see if I do to string. just do that. To string. Boom. In the FS driver, I've got to create a new method called flush table. What happens if you run two of these things at the same time? Well, then you're in trouble. Anyway, this is super ghetto. Yeah. So this is a string, and this is table data. Table data, which is of type any, and then in here, all we got to do is we got to go fs.write file sync. Write file sync. This.get file name. Table file name for the table name. And then JSON stringify the data. So JSON stringify table data null, two spaces like that. That's it. Okay, so this thing does not handle concurrent access at all. I could have it wait on lock, but I'm not going to do that. Yuck. You know what? If the JSON record doesn't have an ID, I could just go straight to this, right? Yeah, okay, so if this JSON record doesn't have an ID, so then JSON record.id equals new UUID, I guess. Okay, so we'll use underscore ID for this. Like that. And then we're gonna use a UUID. Is there a UUID library or do I need to install it? ENPMI UUID. And we'll insert v4 as UUID. Like that. So create a new UUID for it. You only need to do this if it has a UUID. And then all we need to do here is just table.push it in. And what we're going to push in is this. What's it not liking about this? Let's install this. Could do like locking, yeah, but that's complex. Let's make it real minimal implementation to begin with. Not the right type. Yeah, for the return, that's cool. Okay, so we're gonna push this thing in. Table.push. Why is this out of whack like that? I've forgotten a... okay, otherwise I need to do this. Okay. I guess I could do function create new record. Create new record. There's two cases in which that happens. There's no existing record or the record has no ID on it. And this thing takes a JSON record. Just type any. Oh yeah, okay, so really what this looks like is this. And then so I just return this. Create new record out of the JSON record. Nope. Flush the table. I'll deal with that in a second. Find the existing record. Yep, update it if it exists. Now, if it doesn't exist, I gotta be careful because I need to put this in an else block because it'll find that record straight after running that. I'm not happy with this many else's though. Okay. It's obvious what I'm doing there. And that's really all there is to that. Okay, so I think what we need to do is this. Let new record in here. Okay, so in that case here I need to do new record equals extract to constant and enclosing scope and call it new record. Okay. Same thing here. In that case, I need to do this. And then this to get it into the table. And then what we will return is we'll return the new record. There you go. Winning. Upsert working. Let's test it. See if it works. Okay, so upsert. Upsert. Test.ts. I wonder if my parameters test was even running. Let's see. Upsert test. No, that failed. Let's see what failed. Oh yeah, it's this thing here. It's cool. Upsert. Definitely exporting it, so I'll have to manually import it. src/operations/upsert. Upsert. Okay. It's gonna need a config, so it wants what? Operation, which is upsert. Base directory. Temp. Which we'll add to the getignore. While we're at it, we'll add VS Code in here. TMP. Okay, base directory. Table is what? Customers. And then record. Okay, name. Joe Blogs. Address. 1001 Riverside Drive. Now, okay, we should expect record dot underscore result dot underscore ID not to be null. No, not, yeah, not to be null. Okay, let's see if the test will run now. And we should see a temp directory appear in here as it runs. Okay, we did get a temp directory, but what happened? fs write sync no such file or directory. Okay. Okay, it didn't deep create the table. Right. Okay. Pretty simple. const file name, file path actually. Equals. Oh, minus the name. Well, okay. So we do it like this. We know it runs in Ubuntu, so we don't need to worry about like path.join or anything, because this is ghetto.db. Data.json. Okay, let me look at that. File doesn't exist, create it, and then write the file. Yep, that should work. We should see a data.json file appear here. There it is. Temp customers data.json. All right. Pretty cool. Okay, let's I guess the next thing to do would be I could put testing finding this record as well. We probably don't have the ID. I have to run it on a query. Well, let's just do this. Let's say that he lives at the White House. The White House, and I'm not going to bother automating this. Let's do it manually. This is the new record we're going to upsert, and then so I'm going to grab this ID. Comma, put this in, save that, and run it. And then what we should see is this mutates this exact record. Oh. Legal operation on a directory read. Okay, my read file, my read table. Okay, putting the same thing in two places, anti-pattern, but whatever, it's the ghetto. Okay, read it. Nope, didn't like it. What didn't it like? Yeah, okay. Okay, so let's change this. Rename the symbol to get table directory. Private get table name. Get table file. And then you pass in a table name string. Just copy this. Okay, so if we go back up here, this one should be get table file. Ta-da! That's all you need. We can just go back to this file name. Table file equals this dot get table file for the table name. And so we just write it into the table file. And run. Move Joe to the White House. Let's close it and then try reopening it. No, okay, it wrote into the wrong place. FS driver. Flush the table. Yeah, table file. Okay, that's what I forgot. / data.json. Maybe you just write it into table.json. That'd be easier, actually. Like that. Yeah, in which case let's run this again. It'll write into customers.json. Actually, in that case, what we need then is we don't need table directory. So we create the base dir, and then the table file just becomes this.base dir. We never need to get the table directory because we created on startup. Which makes this a lot more simple. Yeah, that's better. So in that case, we can delete this whole temp directory and run it again. And temp customers.json. Here is at the White House. Let's insert another record. Copy that, paste it down here, comment it out. So let's do a customer record for Jane Doe, who also lives at the White House. No ID on that. Yeah. Run the test. So we should see Jane Doe get inserted into this database. Okay. Now, if we now swap that out for this one. And we'll move into the brown house. The dog house. Okay, so we're going to put Joe Blogs into the dog house. Nope. Okay, so what went wrong there? He didn't even get updated. Let's have a look. Customers.json. So Jane's record was created after Joe's, so he didn't get updated. 18E. Upsert test. 18E, yeah. Upsert. Joe Blogs, yeah, okay, so it goes through, it's looking for, let's have a look at my upsert operation. The JSON record doesn't have an ID, create an ID and add it to the record. Yeah, if it does, then let's filter through the existing table, looking at each record, check to see if the record ID is... Dude. Okay, that... JavaScript, the bad parts. Assignment instead of... That still didn't work. Try it one more time. Nope. So, upsert. We got the table. We're going to go through each record in the table. It's a record. Yep, we'll check the ID to see if it's equal to the JSON record ID. If it is, new record is equal to everything that's in the JSON record, but with a new updated change the updated on it. Assign it to the existing record, which is part of the table. Then we flush the table. Let's try this. Some ghetto debugging. Let's log out the new record. And then here we'll log out the table. Console log the table. See if this gives us any insight. Save that. And then run the tests again. npm test. Okay, here's the new record. So it did not get inserted into that table. Okay, why is that? Is it because... Let's have a look at the test that I ran. Node. I mutated something on there. I didn't change the object reference. That's why. Really? Do I slice them out of the table? I mean, I could do a filter on that table. It's not designed for working with large tables, but I would do a filter on the table, slice that guy's record out. So, if the okay, there'll be a faster way to do this, but this will get it done. If he doesn't exist, if that record is not in there, otherwise, I could do this. This is computationally expensive for large data sets, the only thing, but whatever. I'm going to have to do a let here because I'm going to change the object reference. So it's going to use a lot of memory, whatever. And then in here I test to see whether it's the record I'm replacing. If it is, I'm going to return this. Otherwise, I'm going to return the record. Like that. Get rid of that. Yuck. Okay. This is like one of those coding tests where they give you those ON things. Or O squared or whatever it is. Okay, so that's the quickest ghetto way I can think of to do it. Computationally expensive, but we're not talking about large data sets. It's just for demos. Okay, let's have a look. Doghouse. Yep, he got updated. Oh, Jane got destroyed. It did not work. Jane got overwritten. Let's have a look. Upsert. So, okay, there's an existing record, right? We found an existing record, so now we map over all the records in the table, and then if the record ID is equal to the JSON record ID, then we return the JSON record with a new update, or we return the existing record if it's not a match. What I do wrong in there? The JSON record that comes and has no ID, it's just going to be a new record. We do that and move on. Yep. Otherwise, we find an existing record, push the new record in. Yep. Otherwise, we map over the existing table. For each record, we check to see whether the record ID equals the JSON record ID. If it is the JSON record ID, it's the same one. Then we're going to return this. Otherwise we return that. Let's have a look. Just overwritten both of them. So what it's done is it's returned this. Okay, that's a bit weird. Yeah, they have the same ID. How'd that happen? Go back to the test and let's do Jane Doe again. Jane Doe. Address at the White House. And no ID. Okay, so she should get added to the database. She got added. Now if I go back to upsert, oh. One thing. Any? Okay. Ta-da! How's that? Okay, so okay, cool. So then the next thing that we need to do is we could create a table and specify what the index is on it. That would probably be easier. Have a create table operation. And then you'd have an index field. Return the record because they want to update an existing record. Yeah, no, whatever. It's good. We should make a find one in that case. Find one method. Oh, I'll make find as find one. Oh, but what if you want to find many? Huh. Okay. So let's fix this problem first. Okay, so let's grab this record. Save that for further testing. grab this record here. Put that in there. Run the test. Okay, it magically works. I don't know what that's about. Upsert test. Move him to the doghouse. Run the test. And he's in the doghouse. And Jane Doe is still in the White House. First female US president. There you go. Okay, that works, kinda. Okay, cool. I'm calling that working. Yep. I say that works. And then I think the next thing to do then at the end of that test to clean up would be fs remove. Nah, leave it. It's fine. Yeah, I'll test a couple in a row, so I'll do find one and find many. Instead of find, it has to be find one or find many. Yeah, okay. Okay. Find one and find many. So easy. Good. See, I don't have to add any more cases. This makes it easier to refactor. Find one, find many. Okay. Good. So in here, we also need a find one and find many. See how my type system is now flowing through? Find many. Not implemented yet. And as far as upsert is concerned, well, ta-da. There we go. Good. Let's do find one then. Operations find one. Find one .ts. Okay, this should be a lot easier. I'm going to crib from upsert how that starts. Really with this. Find one. Okay. Yeah, file system driver. That's cool. Hang on. Why is the file system driver in upsert? Okay, yeah, it should be called a database driver or something, but that's cool. And this one is called find one, right? Find one. Find one. Okay, so the config that comes in, what we're going to do here is we're going to go const, so we need a table name. No, it's just table. I'm going to assert that it's a string up here, and I'm going to say that it comes off the config.string, so table, as string. So I'll make the assertion in one place. Const query. Okay, so the query is going to be of type any, and it's going to come off the config.query. First thing we need to do is get the table. Okay, so get a new file system driver first. Should do DB, not... Yeah, see? Should be called a database driver. If we have a look at the methods that this FS driver does, it does read table, flush table. Yeah. So let's call this a database driver. Rename the symbol, we'll call it a database driver. Ta-da! New database driver. Upsert, change there. And then rename this symbol from FS to DB. DB read table, that's better. Go back to find one. And also const base dir, which I'm saying is a string, equals config dot base dir as string. Const db equals new database driver, pass in the base dir. So const table equals new table. No, equals db dot get table, read table, table name. Where? Okay, so here we'll make this table name. Maybe I could call it data. So leave that as table and rename this one as data. Okay, so now what we're going to do is we're going to do const results. This is the result set. Equals data dot. So we're going to do a filter. And then I'm going to create a function, filter function here. Query filter. This can just blow up if it doesn't work. Yeah, okay, so you can make that as string in here and take the assertion off that. Oh, that will be anyway, we'll leave it like that. So data filter. Oh yeah, the query filter. So this is value index array. Okay. Okay, actually I think I just need value. And then what we need to do in here is we've got to compare the two things. So, and it's got to be complete. So object, let's see, dot keys of the query that we have. So for each of those keys, and then we'll do a map on that, and then we'll go like this, key. So value key equals query key. Okay, now if everything in here matches, we're going to map, and then what we need to do is reduce. I'm going to reduce this thing down. Okay. This I'm going to need to test because this has got some implicit assumptions in it. So I got to do this out here. Function create query filter. Takes a query, returns a query filter. Type any. Just going to return a function. Okay, yeah, okay, fine. Yep. Takes the value of any. Okay. So we map over the keys of the query. And then we have an array which has map. Yeah, true, false, true, false, true, false, like that. So actually what I want to do is I want to filter. Nope. No. I want to map. This is a statement of whether this is a match or not. Okay, so now I'm going to reduce. It takes a callback function, previous, current, and index. So previous. And current. And this just returns previous and current. And I seed it with true. And what this will do is it will reduce this down to a Boolean value. So this function, so it returns a function. The value. Okay, got to return this. Returns a Boolean value. It's a match or not. So here I create a query filter with the query. And then this new filter here, I just pass it through this new query filter. Okay. So if results.length is greater than 0, return results 0. And not just that, but do we JSON? No, we JSON stringify it on the other side. But the return signature is not correct. Why is it not detecting that? I would expect it to say you don't have the right return signature. What if the table doesn't exist? Let's have a look at read table. If it exists, otherwise return nothing. Okay, that's fine. Find one, okay. Otherwise, I don't think I'm going to return errors. I'm just going to return nothing. Maybe we need to return. Yeah, I need a return signature. Like this. Found true. Record. Like that. Else return found false. Love it. There we go. Okay, if I'm JSON stringifying the result, okay, it's fine. Okay, it's got the wrong time of this error and result, so we're not gonna return errors. We're just gonna throw them. So if I go to this, go to the definition. Whatever, I'll just keep it the way it is. Result, comma, error none. null. Otherwise, return the result is found false. Return. Result that error null. Error null. Okay, save that. Not reformatting so it doesn't like it. Let's try whacking extra one of those and that did it. Okay. Pretty simple. Okay, so if I export this, I can write a test for this. Okay, upsert test. This is find one test. Test.ts. Import from src operations find one. That. Create query filter. So we're going to test the query filter. Okay, here's the data. It's an array of records, right? Let's say it's JSON, JavaScript. Name. Let's use our, probably lift this out into a data set. Go blogs, address White House. And let's put Jane Doe in here. Schemaless database. Now she's in the doghouse. Okay, so we do const query filter. We'll do one query filter, which is we're looking for someone who has a name that's equal to Joe Blogs, right? Let's just go create query filter straight out of that like this. And then if I go, let's just log it out to start with, console log and its data filter on the query filter. And let's just run the test, see what happens. There it is, found it. Let's just test that the negative also will come back with nothing. Yep, nothing. And let's find someone based on where they live. Find me someone who lives at the doghouse. Okay, cool. I mean, I could delete the database and then run all the operations over it just to make sure they're all working. That would work. Like in a single test. Okay, I'll do that later. But anyway, we have find one that works now. So operations index, find one. Find one. Okay, so delete should run a find one operation and then do a delete on that. Delete many, maybe? Delete one and delete many. Okay, so delete is going to need to do a find one, so I probably need to extract this out. Even for find many, find many uses a lot of the same. I mean, find many, the only difference is that this returns 0 and the other one returns like the entire result set. It's records. So the facade is really the only thing that changes. Okay, well I can switch on the operation at the top. That's easy enough to do, like this. Find, right? Operation. I could probably put delete in here as well, and just instead of returning it, just remove them and rewrite it. Pretty tight coupling of code, but whatever. Okay, that's what's wrong. Equals config dot operation. Yeah. Okay, this is pretty easy. Well, and here I just need to do, this is where I can do a case operation, switch. If I'm gonna, I just, yeah. Okay. We're just gonna do find one, find many to begin with, right? So case. And in case it's find one, now in case it's find one, it's going to be return this. Cut. Okay, in the case of find one, we return this. In the case of find many, we just return records and we return all the results, and that's it. Yep. Okay. So if I go into my operations where we have find, we just call this find. We call this find. Find many is now implemented as well. Boom. And delete is really the same thing as find, so we should change this, rename this to find. It's probably going to break a couple of things, well, one thing only here. It's the only place it's imported. Also, this FS driver, I want to change the name of this file to rename to DB driver. Not delete. Rename this DB driver. DB driver. Winning. Okay. So, yep. There was a TypeScript refactor thing that could do it, but only in 2 places that it gets imported. I think I'll write an overall test suite that just exercises the whole database functionality, and that's it. It's the easiest, I think. Okay, let's just make sure the tests that I do have are still running. Yep, they run. Okay. One failed. Which one failed? Find one test. Okay, yeah. Wonder what happens if I pass in a query filter for nothing. Let's see. What happens if I do this? Let's see. What's that going to return? Everything. Well, that's pretty cool. Okay. Oh, yeah, that's what I meant it to do. I did have a suspicion it would do that. Okay, so cool. Where's that log statement with these things? Don't need this. And then the other thing that I should do in here is if that query filter can't be parsed. Like, what if the query filter has got nothing in it if they don't specify a query filter? No, they have to. Okay, but delete. What about delete? Because delete is of the same nature as this, really. Delete one, delete many. Upsert also, maybe, because does upsert take a query at the moment? Okay. Okay, then what I need to do is I need to refactor this out into its own file. Okay. Winning. So my test will now break. Like that. Because what I'm going to do is I'm going to make it possible for you to bring in a query, right? Okay, so query equals config.query. Now, if there's no query, or if the query equals an empty string, I'll do it like this. Okay, if there's no query filter, or they passed in a empty string, so maybe that's the default to that, then it's going to be create query filter. If there's no other query, just then the query filter is, you know, what does the query filter take? What do you mean you can't find it? Import it. No. Query any. So the query will be where the ID is equal to the record ID. The JSON record ID, but we need to do it after this. Okay. Get rid of that. Take this off here and put it down here. JSON record ID. Okay, it'll get ignored down there. It won't be used, so that's okay. Otherwise, create a query filter out of the actual query that they passed in. So now you can use a query to update. And if you don't, it'll do it on the ID of the record. I like it. It's now optional to have a query filter and an upsert. So here, instead of using that, we'll use the query filter. Let's see if upsert still works. So close all the others, right? Let's have a look at our customers.json. Okay, let's move Joe Blogs to Kanye's house. Run. Joe Blog should now move to Kanye's house. Yep. Okay, that works. Okay, so now we're going to do something real weird. We're going to do this. What doesn't it like about that? Comma. Now we're going to replace Jane Doe's record. Jane Doe. What happens if I take off the ID? Okay, so I think this will update Jane, but it will scrub her ID, so we'll have to... no, actually it'll keep the same ID. Okay, that didn't work. Couldn't match her. Why is that? Let's have a look. I got a JSON parse it, that's why. Cert. Okay, so query filter equals this, so here you got a JSON parse it. Nah, not handling errors. Okay. So I should be able to now, in my customer database, delete the second record here. Save that. Run my test, and it should do something to Jane Doe. Nope. Mm-hmm. My query filter. And a query, which is an object. Okay, for each of the keys on the query, passing in a value, a record. Passing the record, and then we go over each of those to check if that's on there. There's nowhere I can insert a console log in there. Well, an easy way to do it would be to take this off. Like this. And then when we do the query filter, in here I create the query filter. I see what the problem is. No. Okay. Yeah, one of my assumptions has changed there. So, okay, this is only if we're looking for it on the JSON ID. So this record has no JSON ID. I mean, if this JSON record doesn't have an ID, then this query filter there should be no query filter. Okay. Okay. Oh gosh. This really is so okay, so where I'd need to do this is like this. So const query equals, and then what? Okay, so lift this to here. Okay, so the query, if there's no query of that, then it's undefined. Otherwise, it should be this. Okay. Okay, and there's no query. Yeah, okay, that should work. So if I go back to my customer database, delete this, we're going to overwrite Jane Doe's record with Joe Bloggs' record. No, that didn't do it either. Upsert test. I passed in this query here. So it runs in the top here. It goes false. Query equals that. False. Query equals, okay. No query was passed in. So that's false, and that's false. Hang on, if not, that's actually, this thing is true. So that's if there is no query, if no query was passed in. Okay, well I passed in a query, so that should evaluate to, that evaluates to false. That evaluates to false. So the query evaluates to undefined. Let's have a look at my upsert in the test. Yeah, it doesn't have an ID on it. Hang on, I passed in a query. So I passed in a query. So that should be... false. Yeah, okay. If the query is like empty. Or if there's no query, then the if the query is false or there was no query passed in, it will be undefined. It will evaluate to false. It will evaluate to false. So if I passed in a query, if query is true, okay, this is the logic I need. Okay, yep, there we go. Okay, so, let's run it now. Should overwrite Jane's record with this new Joe Bloggs record. Nope, it did not. It created a new record. Okay, so let's go to upsert. We'll just console log out the query here. Console.log query. Okay, I've got the same problem here. That's why. Already Jason parsed it above, so this should be a query here. There's no query and the record has no ID. Yeah, okay, that should do it. I need to test on two different conditions, a user-defined query or a system-defined one. .24 undefined, console log query undefined. If query is it's not equal to that, and there is something, query is not getting passed through. Same behavior. Okay, let's have a look. My test, I'm passing in a query, so it's definitely getting a query in its configuration. Yep. So it comes down here. Okay, query equals, okay, my query is not equal to that, and there is a query. So anyway, for kind of like readability, I should reverse those two because it's got short circuit evaluation as well. If there's no query, it's just going to bail. If there's a query and the query is not equal to that, then these two conditions should be reversed. That's why. Okay. Okay, this should do it. Query, give me my good query. There it is. Yep. And in the database, nope, we added another record still. Okay. At least we know the query is getting passed in now. if there is a query, these two need to be reversed as well. Okay. Let's just mutate this database. Yep. Okay, run. Yeah, I'm gonna do one test to exercise everything, I think. No, she didn't get updated. In my test, I was going to... Yeah. Actually, you know what? We'll change her name to Jane Logs. Upsert should actually be update. Yeah, we need an update. Okay, let's get this upsert to work first, then I'll have to do the same thing I did with find one, find many, update and upsert. Okay, so we've got the query filter. If there's a query, create a query filter out of this. Yep. If the new record doesn't have an ID and there's no query, then we're just going to create a new record. Okay, otherwise, we're looking for the existing record using the query filter. Fine. Okay. What does my query filter do? No, it just returns a boolean, so... Well, that's funny because it didn't do anything. It should have done something. That's weird. This condition is no ID. And no query. Console looking for new word phrase. Looking for existing record. Okay. Found new record. Found existing record. Debug, no existing record found, creating new. Because I'm putting a bunch of console logs and I use this to find them with that debug thing. No existing record found, creating new. Okay, let's run the test, see what happens. Tell me what you're doing. Upsert, looking for existing record. No existing record found, creating new. And yet, there's no new record written to the database. Let's have a look. Customers.json. Nope. Upsert, no existing record found. Oh. Okay, so this one here is actually... Okay, I see. My update mechanism is wrong. Ooh, okay. Yeah, okay. It's an assumption here. This should be existing record. What if I want to do update many? This one has found existing record. Got those around the wrong way. This should do it. Jane Blogs has moved to Kanye's house. So Jane and Joe got married, they moved to Kanye's place. Okay, it works. Update many. What about if we wanted to do update many? Worry about that later. Okay. I better document this before I forget how it works. Take that out. Okay, so we'll insert a new record if no match is found. We'll match on _ID unless a query is specified. In which case it'll match on it'll update the first match or insert a new record. Okay, works. Well, let's do a find many test, hey? Rename this to find test. Let's see if we put them into both in the doghouse. So if we filter on QF, in the find test we get both of them back. Okay, so find many works.